The afternoon sun hung low over Vladivostok on July 29, 1944, when Captain Howard Jarrell felt his B-29 Superfortress shudder beneath him. The No. 3 engine had been coughing black smoke for the last 200 miles, and his fuel gauges showed needles dropping toward empty faster than they should. Below him, Soviet territory stretched in every direction. Behind him, somewhere over the Sea of Japan, lay the target they'd just bombed in Manchuria. Ahead, theoretically, lay China and safety. But the mathematics of fuel consumption don't negotiate with hope. Jarrell keyed his intercom. "We're going to Vladivostok." His co-pilot turned, eyes wide. The crew knew what that meant. The Soviet Union wasn't at war with Japan. Their orders were explicit. Avoid Soviet territory except in absolute emergency. Land there, and internment was guaranteed, but crash into the Sea of Japan with a dying engine, and death was certain. The Boeing B-29 Superfortress, designated EB-IR, ramp-tramp banked left, turning toward the Soviet naval base. None of the 11 men aboard could have imagined that this emergency landing would change the strategic balance of the Cold War, that their aircraft, one of America's most closely guarded secrets, would be dismantled rivet by rivet and copied with such precision that Soviet engineers would reproduce a stray American wrench accidentally left in the fuselage. Joseph Stalin would order this single airplane transformed into 847 exact duplicates, creating the Soviet Union's first true strategic bombing force. The central question of this story is deceptively simple. How did a handful of emergency landings hand the Soviet Union the technology to threaten American cities with nuclear weapons? The answer reveals how the most expensive weapons program in American history, more costly than the Manhattan Project itself, became a gift to a future adversary through nothing more than mechanical failure and international law. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. To understand the magnitude of what landed at Vladivostok that July afternoon, you must first understand what the B-29 represented in 1944. The Superfortress wasn't simply another bomber. It was a statement of American industrial supremacy, a flying embodiment of technology so advanced it made contemporary aircraft look like relics from a previous war. Boeing's engineers had created something unprecedented. Where the B-17 Flying Fortress carried a maximum bomb load of 8,000 pounds, the B-29 could deliver 20,000 pounds of explosives. Where the B-17 struggled to reach 30,000 feet, the B-29 cruised comfortably at 33,000 feet, above the effective ceiling of most Japanese fighters and anti-aircraft guns. Its 4 Wright R-3350 engines, each producing 2,200 horsepower, drove the aircraft to speeds exceeding 350 miles per hour. But the B-29's true innovation lay hidden inside its aluminum skin. The entire crew compartment was pressurized, allowing 11 men to work in shirt sleeves at altitudes where the outside air temperature dropped to 50 degrees below zero. A central fire control system, operated by an analog computer, automatically calculated lead angles for the remote-controlled gun turrets, adjusting for airspeed, altitude, temperature, and gravity. A single gunner could direct 4 turrets simultaneously, tracking targets through a complex system of optics and gyroscopes that represented the cutting edge of fire control technology. The United States Army Air Forces had spent $3 billion developing the B-29. Adjusted for inflation to modern currency, that figure approaches $42 billion. To put that in perspective, that exceeded the entire budget allocated to the Manhattan Project. 4 massive production facilities across the United States operated around the clock. Boeing's plants in Wichita, Kansas and Renton, Washington, Glen L., Martin's facility in Nebraska, and Bell Aircraft's operation in Georgia together employed tens of thousands of workers, each contributing to the production of what was essentially a flying computer wrapped in pressurized aluminum. The Soviet Union had nothing comparable. The VVS, the Soviet Air Force, remained fundamentally a tactical force, designed to support ground operations within a few hundred miles of the front lines. Their heaviest bomber, the Petlyakov P-8, struggled with reliability problems. Only 93 P-8 seconds were built during the entire war. While Britain and America deployed thousands of heavy bombers, Stalin's Air Force focused on sturdy, simple aircraft like the Ilyushin Il-2 Sturmovik ground attack plane and the Yakovlev fighters that dueled with the Luftwaffe over burning cities from Stalingrad to Berlin. Stalin understood the strategic implications of this disparity. A nation without long-range bombers could not project power beyond its immediate borders, could not threaten an enemy's industrial base deep inside their territory, could not, in the emerging age of atomic weapons, deliver nuclear warheads to distant cities. The Soviet leader had requested B-29 seconds through the Lend-Lease program, not once, but twice. Both times, Washington politely declined. The Americans had good reason for refusal. The B-29 represented years of developmental work and billions of dollars in investment. Sharing it meant handing a potential adversary the blueprint for strategic air power. And by mid-1944, despite the continuing alliance against Germany and Japan, tensions were already emerging between Moscow and Washington. Which brings us back to Captain Jarrell and his crew, circling over Vladivostok with a sputtering engine and empty fuel tanks. They had no choice in the matter. International law was clear. The Soviet Union maintained a neutrality pact with Japan, signed in April 1941 and valid for 5 years. That pact stipulated that if either party became involved in hostilities with a third power, the other would remain neutral. For Stalin, this wasn't diplomatic nicety, it was survival. In 1944, the bulk of Soviet forces remained locked in desperate combat with Nazi Germany. The Red Army couldn't afford a two-front war. The poorly defended Soviet garrison at Vladivostok sat within easy striking distance of Japanese armies occupying Korea and Manchuria. One misstep, one provocation, and Japan might decide that neutrality pact wasn't worth the paper it was printed on. Consequently, when American aircraft crossed into Soviet airspace seeking emergency refuge, Moscow had to enforce the law. The crews would be interned. The aircraft would be impounded. Under international law, a neutral nation couldn't simply refuel a belligerent's military aircraft and send it back into combat. The crews understood this. Their briefings had been explicit. Land in Vladivostok only in absolute emergency. Everything else, fuel state, damage, wounded crew, came second to avoiding internment. But mechanical reality doesn't respect diplomatic considerations. As Ramp-Tramp descended toward the Soviet naval airbase at Tsentralnaya Uglovaya, 30 kilometers east of Vladivostok, Jarrell had already accepted what came next. Internment, yes, but internment meant survival. His 11-man crew would live through the war. They would eventually return home. What neither Jarrell nor anyone in Washington could have predicted was what would happen to his aircraft. The B-29 touched down on Soviet soil at approximately 4:30 in the afternoon, local time. Soviet guards immediately surrounded the aircraft, weapons raised. Jarrell and his crew were ordered out at gunpoint. They spent the first week in isolation, questioned repeatedly by Soviet military intelligence officers, and denied contact with the American consulate. The treatment wasn't brutal by Soviet standards, but it was thorough. The NKVD wanted every detail: training procedures, operational tactics, technical specifications. Jarrell and his crew gave the minimum required by military code name, rank, serial number. But the Soviets already had what they really wanted. They had the airplane itself. Within hours of Ramp-Tramp's landing, telegraph messages flashed from Vladivostok to Moscow. Senior Soviet aviation officials recognized immediately what had fallen into their hands. This wasn't a B-17 or B-24 aircraft the Soviets had already examined from previous emergency landings. This was the B-29, the bomber that American newspapers called a Superfortress, the aircraft whose existence had been rumored but whose capabilities remained largely unknown outside of Washington. 3 days later, a transport aircraft arrived at Vladivostok, carrying a team of Soviet aviation engineers. They photographed Ramp-Tramp from every angle. They measured every dimension. They examined the engines, the pressurization system, and the fire control computer. They compiled reports running to hundreds of pages, detailing every innovation, every system, every component that made the B-29 superior to anything in the Soviet inventory. And they waited, because in Moscow, Joseph Stalin was making a decision that would reshape Soviet air power for the next decade. Captain Howard Jarrell wasn't the only American airman who would make an emergency landing in Soviet territory that summer and fall. On August 20th, 1944, another B-29, designated Kate Paumat II, suffered catastrophic engine failure during a raid on Japanese targets. The crew bailed out over Soviet territory near Khabarovsk. The aircraft crashed, but Soviet recovery teams salvaged substantial wreckage. Then, on November 11th, the General H. Arnold Special limped into Vladivostok after sustaining damage during a night raid on Omura in Kyushu, Japan. 10 days later, on November 21st, a fourth B-29 named Ding Hao joined the growing Soviet collection. The crew of Ding Hao experienced the same reception as Jarrell. Lieutenant John Schaefer, the 22-year-old co-pilot from Michigan, watched Soviet fighters escort them to the same small airfield where Jarrell had landed. As they approached the runway, Schaefer spotted another B-29 on the ramp below. The sight filled him with mixed emotions: relief that they weren't alone, but growing dread about what internment might mean. The Soviet pilots who forced them down weren't hostile exactly. They were professional, efficient, and utterly determined. Ding Hao was directed to land, and the moment the wheels touched Soviet concrete, military vehicles surrounded the aircraft. Schaefer and his crew were ordered out at gunpoint. They were searched, separated, interrogated. Days turned into weeks. Eventually, the crews from all 4 B-29 seconds were transported by train across the Trans-Siberian Railway to Tashkent, deep in Soviet Central Asia. There they joined more than 100 other American airmen who had made emergency landings on Soviet territory during the war. The accommodations weren't brutal, no torture, no starvation, but they weren't comfortable either. The Americans lived in a guarded compound, forbidden from leaving, unable to communicate with home. The Soviet authorities kept them isolated, monitored their conversations, and restricted their movements. International law required that interned airmen be treated humanely, and by the harsh standards of wartime Soviet imprisonment, the Americans were treated reasonably well. But they were prisoners nonetheless, cut off from the war, uncertain when or if they would ever return home. Back in Washington, diplomatic pressure mounted. The State Department lodged formal protests. The American ambassador in Taipei Pieces. Moscow raised the issue repeatedly, but Stalin held firm. The aircraft, he insisted, must remain in Soviet custody. International law justified the internment. The neutrality pact with Japan demanded it. The crews would be released eventually, probably, but the airplanes were a different matter entirely. What the Americans didn't know, what even most of the Soviet engineers examining the captured B-29 seconds didn't know, was the decision Stalin had already made. In a secure office in the Kremlin, surrounded by aviation industry officials and NKVD officers, Stalin had outlined his vision. The Soviet Union would not simply study these captured aircraft and incorporate a few innovations into existing designs. No, the Soviet Union would copy the B-29 exactly, every dimension, every system, every component, bolt for bolt, rivet for rivet. The man Stalin chose to lead this extraordinary project was Andrei Tupolev, the Soviet Union's most accomplished aircraft designer. Tupolev had survived Stalin's purges in the late 1930s barely. He'd been arrested in 1937, accused of passing aircraft designs to Germany. He'd spent time in the gulags, then in a special prison Sharashka where gifted engineers worked on aviation projects under NKVD supervision. By 1944, Tupolev had been rehabilitated, his considerable talents recognized as too valuable to waste. When Stalin summoned him and explained the assignment, Tupolev understood immediately the magnitude and danger of the task. Copy the B-29 exactly. Have the first prototype ready for flight testing within 2 years. Begin mass production shortly thereafter. No excuses, no delays. Stalin didn't need to elaborate on the consequences of failure. Tupolev had already experienced Soviet justice once. He had no desire to repeat that education. The technical challenges were staggering. The B-29 had been designed using American imperial measurements, inches, feet, pounds. Soviet industry operated on the metric system. Every dimension would need converting. But that was merely the beginning of the problems. American aluminum alloys came in different grades and thicknesses than Soviet equivalents. American electrical systems operated on different voltages. American industrial tolerances assumed manufacturing capabilities that Soviet factories often lacked. Consider the tires. The B-29's massive weight required enormous tires, far larger than anything Soviet industry produced. The Soviet tire industry would need to develop entirely new molds, new rubber compounds, new production techniques. Or consider the plexiglass nose. The compound curves of that transparent bombardier's compartment represented a manufacturing challenge that Soviet optical industries had never confronted. Or the engines copying the Wright R-3350's 18-cylinder radial engine would require reverse engineering thousands of precision components, each manufactured to tolerances measured in thousandths of an inch, and Stalin wanted this done in 2 years. Tupolev mobilized the entire Soviet aviation industry. 3 captured B-29 seconds were transported to Moscow Ramp-Tramp, General H.A. Arnold's Special, and Ding Hao. The 4th aircraft, Kate Pyomat II, had crashed too severely for complete reconstruction, but salvaged components were shipped to Moscow for study. 1 complete B-29 would be systematically dismantled, every part catalogued, measured, photographed, and analyzed. The 2nd would remain largely intact as a reference, to be consulted whenever questions arose about how components fit together. The 3rd would be used for flight testing, to verify that Soviet copies performed identically to the American original. Teams of engineers descended on the aircraft. They measured every dimension with calipers and micrometers. They photographed every system from multiple angles. They created detailed technical drawings of every component, no matter how seemingly insignificant. They tested materials, analyzed metallurgy, and examined welding techniques. They discovered hundreds of small innovations, self-sealing fuel tanks, advanced hydraulic systems, sophisticated electrical wiring harnesses that represented incremental improvements over Soviet practice. The scope of the reverse engineering effort was unprecedented. More than 900 Soviet factories would eventually contribute components to what would become the Tupolev Tu-4, the Soviet designation for their copy of the B-29. Each factory received detailed blueprints, converted to metric specifications. Each faced the challenge of producing components to American tolerances, using Soviet equipment and materials. The engineers working under Tupolev discovered that copying an aircraft exactly proved far more difficult than designing a new one from scratch. When you design your own aircraft, you make choices based on available materials and manufacturing capabilities. You design around your limitations. But when you're copying someone else's design, you're forced to match capabilities you might not possess. Soviet aluminum, for instance, came in different gauges than American aluminum. The B-29's skin panels were manufactured to specific thicknesses measured in fractions of an inch. Soviet mills produced sheets measured in millimeters. Simply converting the measurements wasn't enough. The structural calculations depended on exact material properties. Use slightly thicker aluminum, and the aircraft gains weight. Use thinner material, and structural integrity suffers. Every panel had to be re-engineered to match American performance using Soviet materials. The fire control system presented perhaps the greatest challenge. The B-29's General Electric Central Fire Control System represented the most sophisticated weapons guidance technology in the world. Analog computers, mechanical calculating devices using gears, cams, and electrical relays automatically adjusted. The gun turret aim based on dozens of variables. Airspeed, altitude, temperature, humidity, target speed, target angle, all these factors fed into mechanical computers that calculated the precise lead angle needed for bullets to intercept a moving target. Soviet engineers had never built anything comparable. They understood the principles, ballistics, trigonometry, mechanics, but translating those principles into a functioning mechanical computer required manufacturing precision at the limits of Soviet industrial capability. Every gear had to be cut to exact specifications. Every bearing had to operate with minimal friction. Every electrical connection had to function reliably at high altitude and low temperature. Teams of engineers spent months simply understanding how the American fire control system worked. They disassembled it component by component, photographing each stage of disassembly. They traced electrical circuits. They measured gear ratios. They tested mechanical linkages. Only after completely understanding the American design could they begin the process of recreating it using Soviet components and manufacturing techniques. The Wright R-3350 engine represented another monumental challenge. This massive 18-cylinder radial engine produced 2,200 horsepower, making it one of the most powerful piston engines in the world. It was also temperamental, prone to overheating, and required meticulous maintenance. The Americans themselves had struggled with R-3350 reliability during the B-29's development. Soviet engineers would need to copy not just the engine's basic design, but also understand the subtle metallurgical properties that made it function or fail to function under combat conditions. Fortunately, the Soviets had some foundation to build on. They'd been manufacturing copies of the American Wright Cyclone engine under license since before the war. The Shvetsov Ash-73 engine used in Soviet bombers derived from Wright technology, but the R-3350 was far more advanced, far more powerful, and far more complex than earlier Wright designs. Soviet engineers would spend 2 years developing what they designated the Shvetsov Ash-73TK, essentially a metric copy of the R-3350 with minor modifications to accommodate Soviet manufacturing limitations. Tupolev himself was terrified throughout the entire process. He understood that Stalin's order to copy the B-29 exactly wasn't merely a technical specification, it was a survival test. Any deviation from the American original might be interpreted as sabotage. Any delay might be seen as deliberate obstruction. Tupolev had already survived 1 arrest and imprisonment. He knew that Soviet justice operated on suspicion rather than evidence. Success meant survival. Failure meant the gulag, or worse. This fear manifested in obsessive attention to detail. Stories, perhaps apocryphal but illustrative, circulated among Soviet aviation workers about Tupolev's insistence on copying everything. One tale claimed that when engineers found a small hole in one B-29's wing, apparently from battle damage, they asked whether they should include this imperfection in their copy. Tupolev allegedly ordered the hole included, reasoning that Stalin's order had been to copy the aircraft exactly. Another story described engineers discovering an American wrench accidentally left inside the fuselage. Rather than simply removing it, they supposedly photographed it, measured it, and included a metric equivalent in every subsequent Tu-4 production aircraft. These stories are almost certainly exaggerated. Tupolev was a brilliant engineer, not a mindless copyist. He understood that battle damage shouldn't be reproduced. But the stories reflect a deeper truth about the psychological pressure Soviet engineers operated under. They worked knowing that any deviation, any perceived shortcut, any failure to match American performance might be interpreted as treason. The first Soviet-built Tu-4 prototype rolled out of the factory in early 1947. It looked virtually identical to the American B-29. Same wingspan of 141 feet 3 inches, same fuselage length of 99 feet, same distinctive stepped cockpit canopy, same remote-controlled gun turrets. From a distance, even experienced American aviators would have struggled to distinguish a Tu-4 from a genuine B-29. But subtle differences existed. The Soviet copy weighed approximately 340 kilograms more than the American original, a difference of less than 1%, but significant nonetheless. The added weight came from substituted materials, slightly thicker structural elements, and components manufactured to looser tolerances. The Soviet engines, while functionally equivalent to the Wright R-3350, differed in minor details of construction. The fire control system worked on the same principles but used Soviet-manufactured electrical components and mechanical parts. On May 19, 1947, test pilot Nikolai Rybko climbed into the cockpit of the first Soviet-built Tu-4 and prepared for its maiden flight. Tupolev watched from the ground, his career and possibly his life depending on the next hour. If the aircraft failed to fly, if systems malfunctioned, if performance fell short of expectations, the consequences would be severe. The 4 Shvetsov engines coughed to life, their throaty roar echoing across the airfield. Rybko advanced the throttles. The massive bomber accelerated down the runway, gathering speed, and then lifted smoothly into the air. For the next hour, Rybko put the aircraft through basic flight tests. Turns, climbs, descents, stalls. The Tu-4 performed almost exactly like the American B-29 that Soviet engineers had studied so obsessively for the previous 2 years. When Rybko landed and climbed from the cockpit, Tupolev permitted himself a moment of relief. The aircraft flew, systems functioned, performance matched predictions. The most audacious reverse engineering project in aviation history had succeeded. But Stalin wanted more than a successful prototype. He wanted mass production. He wanted hundreds of these aircraft rolling off Soviet assembly lines, creating a strategic bombing force capable of threatening American cities if the Cold War turned hot. Soviet industry mobilized once again, this time shifting from reverse engineering to mass production. The scale of this effort was staggering. More than 900 factories across the Soviet Union contributed components. Aviation plants in Moscow, Kazan, and Kuibyshev assembled complete aircraft. Engine factories produced the Shvetsov Ash-73 TK power plants. Electronics plants built fire control computers. Aluminum mills rolled sheets to precise thicknesses. Tire factories developed new molds for the massive landing gear. Thousands of skilled workers learned new techniques, adapted American manufacturing methods to Soviet equipment, and solved countless small problems that arose when translating imperial measurements to metric specifications. Quality control became a constant struggle. Soviet manufacturing tolerances generally ran looser than American standards. Components that should have been interchangeable sometimes weren't. Engines that should have produced 2,200 horsepower sometimes fell short. Electrical systems that should have been reliable sometimes failed. But gradually, through repetition and experience, Soviet workers improved their techniques. Early Tu-4 seconds required extensive hand-fitting of components. Later aircraft incorporated lessons learned, with better standardization and fewer production defects. By 1949, Soviet factories were producing Tu-4 seconds at a rate of approximately 10 aircraft per month. Not the hundreds per month that American factories had achieved during the war, but sufficient to build a credible strategic bombing force. And unlike the American B-29 seconds, which were being retired from frontline service as jet-powered bombers entered production, the Tu-4 represented the cutting edge of Soviet aviation technology. The West first learned about the Tu-4's existence on August 3, 1947, during the annual Aviation Day celebration at Tushino Airfield outside Moscow. Soviet authorities invited foreign military attaches and journalists to watch a carefully choreographed air show displaying Soviet air power. Jet fighters screamed overhead. Sturmovik ground attack planes demonstrated their capabilities. Transport aircraft paraded past. And then, toward the end of the show, 3 silver bombers approached from the south. Western observers recognized them instantly. B-29 seconds, American aircraft, flying in Soviet markings. The initial reaction was confusion mixed with hope. Perhaps these were the 3 aircraft that had made emergency landings in Vladivostok back in 1944. Perhaps the Soviets were finally returning them, as Washington had repeatedly requested. But the truth was far more disturbing. These weren't captured American aircraft. These were Soviet-built copies. 3 Tu-4 seconds, identical in appearance to B-29 seconds, demonstrated that the Soviet Union now possessed strategic bombing capability equivalent to America's. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The revelation sent shockwaves through Western intelligence services. American military analysts had assumed that Soviet aviation technology lagged years behind Western capabilities. The appearance of jet fighters like the MiG-15 had been concerning but expected. Jet technology was advancing rapidly on both sides, but the Tu-4 represented something different. It demonstrated that the Soviets could not only copy advanced American technology, but could do so with remarkable precision and scale. More concerning was what the Tu-4 made possible. The Soviet Union had successfully tested its first atomic bomb on August 29, 1949. That test, conducted at the Semipalatinsk site in Kazakhstan, proved that Moscow possessed nuclear weapons capability far sooner than American intelligence had predicted. And now the Soviets had an aircraft capable of delivering those weapons. The Tu-4's combat radius of approximately 3,000 miles meant it could strike targets deep inside Europe. It could reach Western European capitals from bases inside the Soviet Union. And while it couldn't quite reach the American mainland from Soviet territory and return, a one-way mission was possible, and Soviet military doctrine didn't rule out such missions. The strategic balance of the early Cold War had fundamentally shifted. American military planners scrambled to respond. The Air Defense Command, responsible for protecting American airspace, received massive budget increases. Radar networks expanded across Alaska, Canada, and the northern United States. Jet interceptors like the F-86 Sabre and F-94 Starfire entered production specifically to counter the Tu-4 threat. Surface-to-air missile development accelerated. The entire architecture of American air defense in the 1950s was shaped by the realization that Soviet bombers' copies of American aircraft could potentially strike American cities. The irony wasn't lost on anyone involved. American technology, captured through mere mechanical failure and international law, had been transformed into one of the primary threats facing the United States in the early Cold War. Captain Jarrell's emergency landing in July 1944 had seemed, at the time, like a minor inconvenience, an unfortunate but ultimately insignificant incident in a vast global war. Instead, it had handed Stalin the capability to threaten the American homeland. For the American airmen who made those emergency landings, the story had a more personal conclusion. The crews remained interned in Soviet Central Asia through the winter of 1944 and into 1945. They lived in guarded compounds, cut off from the war, uncertain of their fate. Soviet authorities treated them reasonably well by wartime standards: adequate food, basic medical care, no systematic abuse, but they remained prisoners nonetheless. In January 1945, a carefully orchestrated escape was arranged. The Americans were transported to the Soviet-Iranian border, where Soviet guards conveniently looked the other way as the internees crossed into Iran, then under Allied occupation. From Iran, they made their way to American military facilities and eventually home. The official story was that they had escaped on their own initiative. The reality was that Moscow and Washington had negotiated their release through back channels, maintaining the fiction of Soviet neutrality toward Japan while quietly resolving a diplomatic irritant. Lieutenant John Schaefer, the co-pilot of Ding Hao, returned to Michigan in September 1945. His official personnel records listed him as missing in action for the period of his internment. The classified nature of his Soviet imprisonment meant that standard records couldn't reflect the truth. It wasn't until 1988, more than 4 decades after the war ended, that Congress officially changed the status of Siberian internees from missing in action to prisoners of war. In 1992, Schaefer finally received the Prisoner of War Medal for his months of internment. Schaefer re-enrolled at the University of Michigan, earned a business degree, and spent 34 years running a family office supply business in Flint. he rarely spoke publicly about his experience. Like many veterans, he viewed his wartime service as something to be quietly remembered rather than constantly discussed. But the question must have haunted him occasionally. What happened to the aircraft he flew that day? What became of Ding Hao after Soviet guards marched him away from the flight line? The answer, had he known it, would have been both fascinating and disturbing. His aircraft became one of 3 complete B-29 seconds systematically studied by Soviet engineers. It was measured, photographed, analyzed, and ultimately used as a reference for the Tu-4 program. Components from Ding Hao might have been installed in early Tu-4 prototypes. Lessons learned from examining his aircraft's systems contributed to Soviet aviation technology for years. Captain Howard Jarrell, pilot of Ramp Tramp, had an even more direct connection to Soviet aviation history. His aircraft, the first B-29 to land in Soviet territory, became the primary template for the entire Tu-4 program. Soviet engineers dismantled Ramp Tramp component by component, creating the detailed technical documentation that would guide the reverse engineering effort. Every dimension, every system, every innovation in Jarrell's aircraft was catalogued and copied. In a bizarre twist, Ramp Tramp itself survived the dismantling process. After Soviet engineers had documented every detail, the aircraft was reassembled and used for flight testing throughout the Tu-4 development program. Soviet test pilots flew Ramp Tramp repeatedly, comparing its handling characteristics to early Tu-4 prototypes. The American-built original served as the standard against which Soviet copies were measured. Ramp Tramp's final flight came in 1948 or 49. Records are unclear when the aircraft was used as a testbed for experimental technologies. By then, the Tu-4 program had moved into mass production, and the American original had served its purpose. What exactly happened to the physical aircraft remains uncertain. Most likely it was scrapped, its aluminum recycled, and its role in Soviet aviation history largely forgotten outside classified archives. The Tu-4 itself remained in Soviet service through 1950s. Production continued until 1952, with a total of 847 aircraft built. For several years, these copied American bombers formed the backbone of Soviet strategic aviation, the primary means by which Moscow could threaten Western Europe and potentially reach American territory. But technology moves forward. By the mid-1950s, jet-powered bombers like the Tupolev Tu-16 Badger were entering service, rendering the propeller-driven Tu-4 obsolete. Jet aircraft flew faster, higher, and with greater efficiency than piston engine designs. The last Tu-4 seconds were retired from frontline bomber squadrons in the early 1960s, though some remained in service for specialized roles, electronic warfare, reconnaissance, engine testing for a few more years. The impact of the Tu-4 program extended far beyond the aircraft itself. The experience of reverse engineering the B-29 taught Soviet engineers invaluable lessons about American pace, manufacturing techniques, quality control processes, and systems integration. Technologies and methods learned during the Tu-4 program influenced subsequent Soviet aircraft designs for decades. The standardization of components, the emphasis on system reliability, the development of advanced fire control computers, all these capabilities, initially copied from American practice, became part of Soviet aviation culture. Perhaps more significantly, the Tu-4 program demonstrated that the Soviet Union could close technological gaps through determined effort and massive resource allocation. Western analysts had assumed that Soviet industry was too backward, too inefficient, too poorly organized to copy advanced Western technology. The Tu-4 proved them wrong. Within 2 years of receiving the first captured B-29, Soviet factories were producing functionally equivalent aircraft in significant numbers. This realization fundamentally shaped Cold War dynamics. If the Soviets could copy a B-29, what else could they copy? What other Western technologies might be vulnerable to reverse engineering? American security services became obsessed with preventing technology transfer. Export controls tightened. Industrial security increased. The entire apparatus of Cold War secrecy partly grew from the understanding that technological advantages could be copied and countered more quickly than anyone had previously assumed. The nuclear dimension added urgency to these concerns. Soviet possession of both atomic weapons and long-range bombers to deliver them meant that mutual vulnerability replaced American invulnerability. Throughout the late 1940s and early 1950s, American civil defense programs assumed that Soviet Tu-4 seconds might appear over American cities at any moment. Air raid drills became routine. Fallout shelters were constructed. The entire psychology of the early Cold War, the constant anxiety about nuclear attack, was made possible by Stalin's decision to copy those captured B-29 seconds. Looking back from our perspective, decades after the Cold War ended, the story of the Tu-4 illuminates several broader truths about technology, espionage, and the unpredictable consequences of seemingly minor events. First, it demonstrates that technological advantage is always temporary. The B-29 represented the apex of American aviation technology in 1944. It cost billions of dollars to develop. It incorporated countless innovations. It gave the United States an unmatched strategic capability, and within 3 years, an adversary had copied it completely, negating that advantage. Second, it reveals how accidents can reshape history. Captain Jarrell didn't make a strategic decision to hand American technology to the Soviets. He made an emergency decision to save his crew's lives. The mechanical failure of a single engine, combined with the arithmetic of fuel consumption, created the circumstances for one of the most significant technology transfers of the 20th century. History often pivots on such contingencies. Third, it illustrates the double-edged nature of industrial capability. American factories' ability to mass-produce extraordinarily complex aircraft like the B-29 won the war against Japan. But that same industrial sophistication made the aircraft copyable. A simpler bomber, less reliant on advanced systems and precision manufacturing, would have been harder for Soviet engineers to reverse engineer. The B-29's sophistication was both its greatest strength and, ultimately, the source of its vulnerability. Fourth, the story highlights the limitations of secrecy as a protection mechanism. The United States went to extraordinary lengths to keep the B-29's capabilities classified. Security at Boeing plants was strict. Information was compartmentalized. Detailed technical data was restricted. And none of it mattered once physical examples of the aircraft fell into Soviet hands. You can classify blueprints, but you can't classify the aircraft itself once an adversary possesses one. Finally, the Tu-4 story reminds us that intentions matter less than consequences. The American airmen who landed in Vladivostok were heroes doing their duty, choosing internment over certain death. They couldn't have predicted that their decisions would enable Soviet strategic aviation. They couldn't have known that the aircraft they flew would be dismantled, copied, and mass-produced. They made the only reasonable choice available given their circumstances. Yet that choice had consequences that resonated for decades. For Stalin, The captured B-29 seconds represented an unexpected gift that solved a strategic problem. The Soviet Union needed a long-range bomber. It lacked the time and resources to develop one from scratch. The captured American aircraft provided a ready-made solution. Stalin's decision to copy rather than merely study these aircraft was characteristic of his approach to technology and power. Take what works, copy it exactly, and deploy it in massive numbers. For Tupolev and the thousands of Soviet engineers who worked on the Tu-4 program, the project represented both opportunity and danger. Success meant advancement, recognition, and survival. Failure meant disgrace, imprisonment, or death. They worked under conditions of immense pressure, knowing that their technical achievements were being judged by a dictator with little patience for excuses. That they succeeded, that they produced 847 operational copies of one of the world's most complex aircraft, stands as a testament to Soviet industrial capability and human determination under duress. For the American military and political establishment, the appearance of Soviet strategic bombers came as a profound shock. Intelligence estimates had consistently underestimated Soviet capabilities. The Tu-4's debut at Tushino in 1947 forced a complete reassessment of the strategic balance. Within 3 months, American defense spending increased dramatically. Air defense systems were expanded. New interceptor aircraft entered development. The arms race that would define the Cold War for the next 4 decades accelerated, driven partly by the realization that American technological advantages were more fragile than anyone had assumed. The crews of those 4 B-29 seconds that landed in Soviet territory knew none of this at the time. They simply wanted to survive, to return home, to resume their lives after the war ended. Most succeeded. They came home, enrolled in universities on the GI Bill, found jobs, raised families, and gradually forgot the anxiety of that day when Soviet fighters forced them to land on foreign soil. But history remembers. The Tupolev Tu-4, NATO reporting name Bull, stands as a monument to one of the most successful reverse engineering projects in military history. Soviet factories would eventually produce nearly as many Tu-4 seconds as American factories produced B-29 seconds for combat operations in the Pacific. Those Soviet bombers, flying with red stars on their tails instead of American white stars, formed the foundation of Soviet strategic aviation until jet technology rendered them obsolete. Today, a few Tu-4 seconds survive in museums. One sits at the Central Air Force Museum in Monino, outside Moscow, its silver aluminum skin gleaming under museum lights. Visitors can walk around it, marvel at its size, and perhaps not realize that every rivet, every panel, every system represents a copy of American technology seized by accident and reproduced through determined effort. The B-29 seconds that made those emergency landings are long gone. Ramp Tramp, dismantled for study and eventually scrapped. Ding Hao, similarly examined and ultimately discarded. General H. Arnold Special, used for testing and then retired. Kate Paumat II, wrecked upon landing and salvaged for parts. None survived the war, but their legacy did, transformed into 847 Soviet copies that shaped Cold War strategy for more than a decade. The central irony of this story remains stark. American industry spent $3 billion developing the B-29 Superfortress. American crews flew these aircraft on dangerous missions against Japan, and 4 mechanical failures handed the technology to a future adversary who copied it exactly and used it to threaten American cities. No espionage was needed. No spy stole blueprints. No mole passed classified documents. Simple mechanical reliability, or the lack thereof, accomplished what no intelligence operation could have managed. Captain Howard Jarrell made the right decision when his No. 3 engine failed over the Sea of Japan that July afternoon in 1944. He saved his crew, but his emergency landing changed the strategic balance of the early Cold War in ways that no one, not Jarrell, not Stalin, not the engineers who would spend 2 years copying his aircraft, could have fully anticipated. History often works that way, transforming tactical decisions into strategic consequences, turning mechanical failures into geopolitical shifts, and proving that accidents can matter as much as intentions. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.